This is a tNavigator training course. We demonstrate our new technology how to turn an ordinary hydrodynamic model into XML project, supporting multiple model realizations, and a practical example of setting up and modeling 21 horizontal well trajectories in less than 5 minutes. So this is the model loaded in Eclipse 100 format. Let's go ahead and convert it into XML project. It's done automatically. During this process, every keyword used in the model becomes an independent include file and can have any number of versions. These keywords versions can be arbitrarily interchanged and combined like building blocks into various versions of the original hydrodynamic model. The correspondence among all the lower and higher level versions are kept track in the XML project file. tNavigator can load and run the model created as XML project. Let's do that. Let's close this one, press open, switch the type to XML. Here it goes, open. Alright, let's inspect it. Let's check out the structure of the loaded XML project. In the list of all the include files, we can now see the Eclipse sections and individual keywords files included in the model. Let's keep going and create interactively various horizontal well trajectories, build the model versions out of them, run the simulations, compare performances, and pick up the best performing ones. To better manage the process, I opened an additional graphical window here and got here the manager of the model versions. In the second graphical window, I got the part of the initial model grid. Now we need to create 7 vertical profiles where we place the different candidates of horizontal well trajectories. Let's do that right here. Let's create the first profile. Let's connect few wells, apply. Let's set the second one starting from a different point. Alright, apply, and keep going like this, finishing number 4 and number 5. And now the last one, number 7. Alright, apply. Okay, we finished. Now let's go to user maps, select the reserves expression in surface conditions, go to 2D and profile. And now let's inspect all 7 profiles. It's number 7, 5, 6, 5, 4, 3, 2, 1. So we got all 7 profiles. Let's now construct the horizontal well trajectories. First, let's choose the time step at which we'd like to introduce our horizontal well. Let's do it from the time step number 10. Alright. Next, we choose profile number 1 and let's create 3 different trajectories in each of the profiles. So at the end we get 21 different versions of the well trajectories. Let's start by doing Ctrl and left click, select deviated well and construct the first trajectory. Let's make it around 700 meter long, 10 perforations, add well, 10 connections. Let's save it as a keyword version file. So we got this in red new version of the schedule. And now add the version of the model which would contain this new schedule. Alright, so we got version number 2 with a new horizontal well and version number 1 without the well. So it's original model. So let's keep going. Let's reset and create a second version of the horizontal well trajectory. So let's move one layer down and do the second version for this profile. Alright, add well, going here, create a new schedule, file version, and now add version of the model. So we get version number 3. So let's keep going through each of the profiles to get all the 21 versions. We're done with profile number 1. Let's go to profile number 2 and create a new well trajectory. Alright, like we did for profile number 1. Okay. Alright, add the well. Let's move to profile number 3 now and continue construction. Alright. Second version of the well trajectory in the profile number 4. Alright. Close to the finish now. Add well. Moving forward in the profile number 6. Okay. Add the well. Create the keyword file right here. Add version. Alright. Okay, all the versions of the schedule files and the corresponding versions of the hydrodynamic models are created and ready to be launched in the queue. To schedule all the versions of the model to be run as a part of the batch queue, let's go to versions, check all the versions and launch them. Let's schedule it first. To do that, let's bring back the main dispatcher menu, go to project and say add versions to queue. As you can see, we get all the versions scheduled. You can close this one and let's close the initial window. Yes, save the project. We select how many CPU cores we are going to use. We leave 4 cores. Let's bring up on the screen the Windows Performance Monitor. Let's start the batch queue. So the jobs will be run one after another. We can see reading model. Model is red in the background and now is calculating. Here we can see the load of all CPU cores of the processor. And let's wait till all the jobs are finished. And then we'll see the results. Alright, half of the models are already calculated. We can check them out in the calculated models folder. We can see accumulated oil, water, gas and injected water for all the batch jobs done. And we can even go ahead and actually inspect the production rates for all these versions. To do that, we need to open the model in XML project format in tNavigator. Then go to graphs and select versions, type of the graph visualization, and then just go and select all the versions which have been calculated. So we can see now in one plot, the production rates, oil rate for all 11 versions calculated. We can go and check out the accumulated rates for different versions. And now let's wait till all the versions are finished and we'll find out which one is the best performing one. All the 21 jobs are finished. We can go ahead and sort out the table and get that version number 18 got most accumulated oil. This is the best trajectory of the horizontal well. This is how all 18 versions look like on the accumulated oil graph. Let's zoom in. This is version 18. Let's open version 18 in a separate window. This is how the best well is performing. This model looks like this. At any moment of time, this XML can be saved as normal Eclipse data file. Thank you very much.